Hi, my name is Shahroz Ahmed, and in this video I'm going to explain you the concept of momentum and impulse. It's a topic of Mechanics 1, and let's start off. So momentum and impulse. So I'll explain you the important points that you have to keep in mind while doing the questions related to this topic. So for the physics students, they are like clear about the concept of momentum and impulse, but let me just mention the formulas and the concept of a bit. So let's suppose we have an object. It has a mass m and it is moving with some velocity v. Then we can say the momentum of this object is mass times velocity, and we represent the momentum with p. And if we say that there are two objects, this object is m1, it is going towards right with velocity v1, and this object is m2, it is moving to the left with a velocity of v2. Then we will say the momentum of this object will be m1 v1, and the momentum of this object will be m2 times negative v2, because we have taken the direction of velocity as positive to the right, so the direction of velocity to the left will be negative. So for this one, the momentum will be negative m2 v2. Alright, so after this, let's discuss the momentum in a collision. So let's suppose we have two objects. This is m1 and it is moving to the right with a velocity of u1. There's another object, this is m2, and it is moving to the left with the velocity of u2. After some time, these two objects collided with each other. This is m1, this is m2, and after some time they started to move in the opposite direction like this. So the velocity of this object m1 became v1, and the velocity of the object m2 became v2. So according to the law of conservation of momentum, the sum of momentum before the collision remains equal to the sum of momentum after the collision. So the sum of momentum before the collision will be equal to m1 u1 plus m2 times negative u2, because the direction of u2 is to the left, and the sum of momentum after the collision will be m1 times negative v1 plus m2 times v2. So because these both are equal, so we can write it as m1 u1 minus m2 u2 equals to negative m1 v1 plus m2 v2. So this is how we can write down the equation for the conservation of momentum. So after the conservation of momentum, let's discuss the concept of impulse. So the concept of impulse is nothing than just the change in momentum. So impulse is simply the change in momentum, which means impulse will be the final momentum minus the initial momentum. Final momentum of an object minus initial momentum. This is simply an impulse. And if we are asked about the force, then the force is related to impulse in such a manner that force is equal to impulse divided by time. The time of the interaction. So these are the important points that you have to know in this topic of momentum and impulse. Now let's move on to the exam related questions, and we'll try to solve them by using these concepts. Alright, so here we have a question. In this question it says particle P has mass m kg and particle Q has mass 3 m kg. The particles are moving in the opposite direction along a smooth horizontal plane where they collided directly. Immediately before the collision, P has speed of 4u and Q has the speed of ku, where k is a constant. As a result of the collision, the direction of the motion of each particle is reversed and the speed of each particle is halved. So the best method of doing this question is to draw a figure. So let's draw the two particles. This is particle P. It has a mass m and it is moving to the right with velocity of 4u. The other particle is particle P. It is it is massive. It is more massive than particle P, so it has mass of 3m, and it is moving to the left with a velocity of ku, and they are collided with each other, like over here. They are collided, and after the collision they moved in the opposite direction. So this is the direction of m in the opposite direction, and its velocity has become halved, so it's 2u. Now the other one, this is P. It has also moved in the opposite direction, and its velocity also has become half, so that would be k by 2u, and we have to work out the value of k. So we will use the law of conservation of momentum, in which the sum of initial momentum is equal to the sum of final momentum. So let's see the sum of initial momentum. That will be m times 4u plus 3m times ku, and the final momentum is, okay, so in this one the velocity of particle q is to the left, so I'll take it as negative ku. So I'm taking the velocity in the rightward direction as positive, and the velocity to the left is negative. So for this one, the velocity to the left will be negative, so it will be like m times negative 2u, plus for this one it will be positive to the right, so it will be like 3m times k by 2u. So now I'll solve it and work out the value of k. So it's simple mathematics, so it's like 4mu minus 3mku equals to negative 2mu plus 3 by 2 kmu. So I'll separate the terms with k and u. So I'll shift the terms with k onto the right side and the simple terms with mu onto the left side. So it'll be like 4mu plus 2mu equals to 3 by 2. In order to write 3 by 2, I'll just write 1.5 kmu plus 3 kmu. So on the left side I'll get 6mu, on the right side I'll get 4.5 kmu. So mu will get cancelled, and k will become equal to 6 over 4.5. So that would be equal to 4 over 3. So the value of k is 4 over 3. Alright, now in part B we have to work out, it says find in terms of m and u the magnitude of the impulse exerted on P by Q. So we have to find out the impulse on P. So we will have to find out the change in momentum of P. So the change in momentum of P will be equal to the final momentum minus the initial momentum. So the final momentum of P is this much, and the initial momentum was this much. So what we do is final momentum minus initial momentum. So it will become negative 2mu minus 4mu. So that would be equal to negative 6mu. So because we are asked only about the magnitude, so it will be 6mu. This negative sign is showing the direction of the momentum that is to the left, because we have taken the direction of momentum positive to the right and negative to the left. So it will be 6mu. So that's the answer. So this is it for this question. Now we'll see another one. Alright, let's see question number 6. It says a particle P of mass 1.5 kilogram is moving along a straight horizontal line with a speed of 3 meters per second. Another particle Q of mass 2.5 kilogram is moving in the opposite direction along the same straight line with a speed of this much. The particles collide. Immediately after the collision, the direction of P is reversed and its speed is 2.5 meters per second. Calculate the speed of Q immediately after the impact. So initially, let's suppose this is particle P and this is particle Q. particle P is moving to the right with a velocity of 3 meters per second. Particle Q is moving to the left with a velocity of 4 meters per second. The mass of particle P is 1.5 kilograms and the mass of particle Q is 2.5 kilogram. They collided, and after the collision, it says immediately after the collision the direction of P is reversed. So the direction of P is over here and its speed is 2.5 meters per second, and we do not know about the direction of Q, so I'll take it as reversed as well, and we have to work out its speed. So let's suppose the speed of Q is v. Now the mass will remain constant, only the speed will change. So I'll apply the law of conservation of momentum over here and work out the speed of particle Q. So the sum of initial momentum will be 3 times 1.5 plus 4 times 2.5. The final momentum is, okay, now this one, in this one that speed is towards left, so I'll take this 4 as -4. It will be like -4 times 2.5. For this one the speed is also to the left, so it will be like -2.5 times 1.5 plus, for this one it will be like to the right, or I have just assumed to the right, so it will be like its mass is 2.5 kilogram, so it will be like 2.5 v. Now I have to work out the value of v, so I'll do some maths to work it out. So 3 times 1.5 will be 4.5 minus 4 times 2.5 is 6 equals to, now -2.5 times 1.5, -3.75 plus 2.5 v. So now I'll shift all the numbers to the left, so it will be like 2.5 minus 6 plus 3.75 whole divided by 2.5 is equal to v. So I'll get v equals to 0.9 positive meters per second. So I have taken the direction to the right as positive, so it will be v equals to 0.9 meters per second to the right. So this is the value for v. Alright, so I'll just erase it and let's move on to part B. In part B it says state whether or not the direction of motion of Q is changed by the collision. Yes, it has changed. Initially it was moving to the left and now it has started moving to the right. Yes, and it has changed from left to right. Now the next one, it says calculate the magnitude of impulse exerted by Q on P, giving the units of your answer. So on P, so we have to find out the change in momentum of P because the impulse has been exerted onto P. So the final momentum of P minus the initial momentum of P. So the impulse will be equal to, the final momentum of P will be -2.5 times 1.5 minus the initial momentum is 1.5 times 3. So from here I'll get -3.75, -4.5. So the total will become -8.25. So negative sign is just showing the direction. So the impulse is -8.25 kilogram meter per second, and the magnitude will only be equal to 8.25. So that's the magnitude, and the unit is kilogram meters per second because the unit of change in momentum and momentum is same. So this is how we do this question. Now let's move on to the third one. Alright, now let's see the next one. It says a tent peg is driven into soft ground by a blow from a hammer. The tent peg has mass 0.2 kilogram and the hammer has mass 3 kilogram. The hammer strikes the peg vertically. Immediately before the impact, the speed of the hammer is 16 meters per second. It is assumed that immediately after the impact, the hammer and peg move together vertically downwards. Find the common velocity common speed of the peg and the hammer immediately after the impact. So for example, this is the peg and here's the hammer. So this hammer is moving downwards with a velocity of 16 meters per second. The mass of the peg is 0.2 kilogram and the mass of the hammer is 3 kilogram. So we'll use the concept of the law of conservation of momentum and work out the final speed. So once the hammer hits the peg, they move with the same velocity. So the initial velocity of the hammer is 16 meters per second and the mass is 3. So the initial momentum of hammer is 3 times 16 plus the initial velocity of the peg is 0 and the mass of the peg is 0.2. So it will be like 0 times 0.2. Now let's see the final. So let's see the both hammer and peg moves with a common velocity, that is v. So I'll say that it will be mass times v plus mass times v. Alright, so on the left side I'll get 48 plus 0, so I won't write 0 over here, equals to 3v plus 0.2v. It will become 3.2v. So my v will become equal to 48 over 3.2. So 48 divided by 3.2 will be equal to 15. So my v will become equal to 15 meters per second. So this is my velocity. Okay, so this is the common velocity by which both the hammer and the peg will move downwards. Now next one, it says until the peg and hammer come to rest, the resistance exerted by the ground is assumed to be constant and of magnitude r newtons. The hammer and peg are brought to rest 0.05 seconds after the impact. Find to 3 segment figures the value of r. So they are basically asking for the force that is being exerted by both the hammer and the peg in the downward direction. Alright, so that force, as I've told you, the force is equal to impulse over time. Now we have to find out the impulse of this peg. So the impulse of this peg will be final momentum minus the initial momentum. So the final momentum of the peg is 15 times 0.2 minus the initial momentum is 0.2 times 0, because initially the peg was at rest. So this is the final momentum of the peg, this is the initial momentum of the peg. But over here, because both are coming down together, so I'll take the mass as combined mass. So it will be like 15 times 3.2 and 0 times 3.2, or I can just say the initial momentum of the peg was 0 times 0.2 whole divided by the time for which they are coming down, so that is 0.05. So now I'll solve it and I'll get the force. So it will be equal to 960 newtons. So the value of r, that is equal to F, 9 is 960 newtons. Alright, so 960 is the force that is due to the change in momentum. But over here we have to consider one more fact, and that is the weight of this peg. Because the peg is going down, so the force is exerted by the ground against the weight of the peg. So we have to add the weight of the peg into this 960. So the total will become 960 plus the weight, that will be equal to 3.2 times 9.81. 3.2 means the weight of the peg and the hammer, because both are coming together in the downward direction. So the force exerted will be in the opposite direction. So we have to add the weight of both of them. So it will be 960 Newton plus 3.2 times 9.81. So we'll get 960 plus 3.2 times 9.81. That would be equal to 31.4. So I'll just take it as 31. Now the final answer, or the final force that is exerted by the ground onto onto the pair of onto the hammer and the peg will be 991 newtons in the upward direction. They're exerting the force in the downward direction, but the force that will be exerted onto them will be in the upward direction. So this is how we will do this. So this is it for the topic of momentum and impulse. It was the topic of Mechanics 1 A-level maths. So I hope you got it. Thank you.